Car crashes are a serious issue. They happen every day. Understanding the science behind them can help keep us safe. Physics plays a big role in how cars behave during a crash. Let's talk about inertia. Inertia is a fundamental concept in physics that describes the tendency of an object to resist changes in its state of motion. Whether an object is at rest or moving, it will continue to do so unless acted upon by an external force. This principle is crucial in understanding how objects behave in our everyday world. Inertia means an object in motion wants to stay in motion. For example, when you're riding a skateboard, you keep moving forward even after you stop pushing. This is because of inertia. A car going fast has a lot of inertia. The faster it goes, the more it wants to keep going in the same direction. This is why high-speed vehicles need powerful brakes to stop. It takes a lot of force to stop it. Momentum is similar. Momentum is the product of an object's mass and velocity. The greater the mass or the faster the velocity, the more momentum an object has. It's the force an object has because of its motion. For instance, a bowling ball has more momentum than a tennis ball when both are rolled at the same speed because the bowling ball is heavier. A heavy, fast car has more momentum than a small, slow car. This is why larger vehicles can cause more damage in collisions. They have more momentum to transfer upon impact. Force is what changes motion. When you push or pull an object, you're applying force to change its state of motion. The amount of force needed depends on the object's mass and the desired acceleration. It's a push or a pull. For example, when you push a swing, you're applying force to set it in motion. Similarly, pulling a wagon requires force to move it forward. In a crash, forces are huge. The sudden stop of a moving vehicle involves massive forces that can cause significant damage. Understanding these forces helps engineers design safer cars and better safety features to protect passengers. Imagine a car hitting a wall. The car stops suddenly. The force of the impact is immense, and the car's structure is designed to handle this force to protect the passengers inside. But your body inside the car wants to keep going due to inertia. Inertia is the tendency of an object to resist changes in its state of motion. When the car stops abruptly, your body continues to move forward at the same speed the car was traveling. That's why we wear seatbelts. Seatbelts are crucial safety devices that restrain our bodies and prevent us from being thrown forward. They apply a force to slow us down safely. The seatbelt stretches slightly to absorb some of the energy, reducing the force on our bodies. Crumple zones in the car are designed to absorb some of the crash energy. These zones are areas of the car that are meant to deform and crumple in a collision. They crumple instead of staying rigid. By crumpling, they absorb some of the energy that would otherwise be transferred to the occupants of the car. This spreads out the force over a longer time, reducing its impact on us. By extending the time over which the collision occurs, the force experienced by the passengers is significantly lessened, making the crash more survivable. We've come a long way in car safety thanks to physics. Over the years, advancements in technology and a deeper understanding of physical forces have revolutionized the way we design and build vehicles. From the materials used in construction to the intricate safety features integrated into modern cars, every aspect is meticulously engineered to protect passengers. Airbags are a great example. These life-saving devices are designed to deploy in milliseconds during a collision, providing a cushion that can significantly reduce the risk of injury. They inflate instantly during a crash. The rapid inflation is triggered by sensors that detect the sudden deceleration of the vehicle, ensuring that the airbags are in place just in time to protect the occupants. This cushions you and spreads out the force of the impact over a larger area. By distributing the force, airbags help to prevent serious injuries that could be caused by the sudden jolt of a crash. Engineers use physics constantly to make cars safer. They study the dynamics of crashes and use this knowledge to innovate and improve safety features. They test different materials and designs. By experimenting with various combinations, they can determine which materials best absorb impact and which designs offer the most protection. They analyze crash data to find ways to reduce injuries. This data is crucial for understanding how different factors contribute to the severity of a crash and how to mitigate those risks. Remember, understanding the physics of car crashes can save lives. By being aware of how safety features work and why they are important, we can make better choices on the road. Drive safely and always buckle up. Seatbelts, airbags, and other safety features are there to protect you, but they can only do their job if you use them correctly. Stay safe out there.